Hello and welcome to an overview of the hardware and capabilities of MSU's High Performance Computing Center, HPCC. In this video, we'll cover the compute resources and file systems available on HPCC, as well as how you can access these resources as an MSU affiliate. Understanding the hardware layout can give you an appreciation for the ways you can parallelize your serial application and the possibilities that HPC can hold for your research. So let's get started. So, what is HPCC? MSU's High Performance Computing Center consists of 4 Linux clusters. Combined, these clusters have over 1,000 computers, also called nodes, that are networked together with very fast network to operate as if they were a single machine with over 56,000 CPU cores, 600 GPUs, and 300 terabytes of memory. The combined theoretical speed of this cluster is 3.9 petaflops. The clusters are purchased by ICER with funds from the Office of Vice President for Research and Innovation. Approximately 60% of the nodes, or computers, within the cluster are bought back and owned by faculty, and 40% remain open for general use. Before we go further, let's just take a look at the few key terms that you'll see over and over again in this presentation. The first is the node, which we just talked about. It's a standalone computer in a box consisting of CPUs, cores, memory, and network interfaces. All the things you would expect to find inside of your standalone compute tower. The term CPU, or socket, or core typically refers to the execution component of a computer. Individual CPUs are subdivided into multiple cores, each with its own execution unit. CPUs with multiple cores form a unit that's called a socket. The word cluster here typically refers to a group of nodes that are networked together so that a program can run on them in parallel. The primary way to get access to HPCC is through your faculty collaborator. All faculty can request accounts for themselves, and thereafter their collaborators. You can use the contact form indicated below to request access. Each account comes with 50 gigabytes of personal disk space, 50 terabytes of scratch space, 500,000 CPU hours, and 10,000 GPU hours in the compute resources. You can request additional storage up to 1 terabyte of personal disk space at no additional cost, with adequate justification. The second way you can get access to the cluster is via the buy-in program. MSU faculty are able to pre-order or purchase a certain number of nodes that live in the cluster. You can then have priority access on these nodes within 4 hours of requesting them. CPU and GPU limits will not apply to these nodes. Lastly, the third way to get access to HPCC is through an education account. These are typically requested by faculty teaching computationally intensive semester-long courses. The way you'd get access is that you'd submit a ticket, letting us know what course you're teaching, the net IDs of the students who will be taking those courses, and any resources you need specifically for that class. This can include software you need installed, shared disk space you'd like available, or any other specific requirements you have. These accounts are typically only open for the duration of the course unless the students transition their accounts to a research or faculty-sponsored account during the time. Like we said before, HPCC is a Linux system, so you can access HPCC by logging into one of our gateway nodes. You can access your files on the system from pretty much any node in the cluster. There are a few exceptions, which we'll go over in a bit. But if you want to test or compile your program and submit your job or analyze your data, you'll need to use the development nodes. Your computation will run on the compute node. In summary, there are a few different types of nodes that are available. Gateway login nodes are available for logging in and doing non-intensive tasks, such as moving files. In addition, the gateway rsync nodes are available for moving data to and from HPCC. These data transfer nodes are configured to facilitate large amounts of data that come and go on HPCC. The development nodes are available for testing, compiling, and submitting your heavy computational workload to the compute nodes. These nodes are typically a representative of the nodes available within the compute cluster. So here we have a conceptual diagram of the HPCC system layout and its networking. You begin here with your laptop or your desktop, and you use some type of protocol to access HPCC via the internet. For the common login, you'd use SSH. For data transfer, you'd use the SFTP or SCP protocols. There are a few utilities that you can also use. rsync and Globus are also additional data transfer utilities that you can use on HPCC. When you log in via SSH, you're logged into one of the gateway login nodes. For file transfer, you can SSH to the rsync gateway node, or use one of the file transfer protocols, SCP, SFTP, rsync, in conjunction with the rsync gateway. All of the nodes on HPCC have access to the file systems. There are 3 that are available: Home, Research, and Scratch file systems. Every node, no matter where you're working from, has access to these file systems, so data stored on Scratch can be accessible on the rsync gateway node, the dev node, and the compute node. The only exception is the gateway login node. Large, high-traffic file transfers are not meant for the login node. Thus, you're not able to access the Scratch disk space via this gateway node. The rsync node for data transfer does have access to the Scratch file system. For the login nodes, you can SSH to the dev nodes to develop, test, and compile your program, and also to submit your request for resources to the Slurm scheduler. The scheduler tries to find a spot where the resources are available, and once those resources become available, your work will run on the compute nodes in one of the partitions on the cluster. We'll discuss some more about how this works when we talk about the rules of the scheduler. So if you want to take a look at the hardware specification of the compute nodes on HPCC, you can follow the link here to our documentation. And here you can see the cluster within which the nodes sit, the names of those nodes, the number of nodes that are within that cluster, and the specifications of the processor, the cores per node, the memory per node, and the disk size, the local disk space that is available. You can also see if the node has a GPU card attached to it or not. So for each cluster, you can see all of the different types of configurations that are available to you. As we just described, there are 3 main file systems on HPCC. Home directory is limited to 1 terabyte of space per user and is designed for your documents, your personal files, and not your research data. Research data should be stored on Scratch. The research space or directory is available for some users. This space can only be requested by regular MSU faculty, and faculty can specify which collaborators should be added to the space. It's designed to archive and store data that is not currently being used. The Scratch file system is designed for computationally intensive workloads. When you're actually doing computation on a set of data, this data should be stored in Scratch. The reason for this is that the home and research file systems are networked with a slower InfiniBand, and computational with data on those systems will bog down the entire system and prevent access to everyone. So please ensure you keep your data in Scratch when you're doing computations that involve large I/O. Each of these file systems has its own purge policy and best practices. So for more details on when to use which storage system, visit the link in the comments below. Within the documentation here, you can see the primary usage of each of these systems. You can see how to access each location in your job script, and you can see the size of the space that is available to you. You can also see the purge policy, which is really important, and you can see some information about best practices in terms of the I/O capability of each system. So let's take a look at how you access HPCC from your own laptop. For Windows systems, you download and install an SSH client. We recommend either MobaXterm or PuTTY. For Mac and Linux systems, you just need to use the terminal that is already available on your computer. So let's take a look here. So you open your terminal, and then to log in, you type SSH followed by your MSU NetID at hpcc.msu.edu. Once the prompt appears, you provide your passcode. There you are. You can see that I'm logged in to the gateway node, and the gateway node I've been assigned to is Gateway 01, and this assignment is typically random. So if you're following along with me, you may be logged in on a different gateway node. And this is because there are several gateway login nodes preventing any single node from becoming overcongested. So here I am in the gateway node, and from here I can select one of these development nodes to do my testing or compiling and submitting a job. And to do that, you just SSH to a dev node. I'm going to select here dev AMD20 because there's a low volume on that development node. And here you can see that my prompt has changed, and now you can see that I'm on a development node. Now, if you'd like to use a GUI application, the -X or -Y flags are usually useful. If you are a Mac user, you may need to install Xcorts. If you're a Windows user and you're using PuTTY, you need to install Xming. If you are using MOBA Xterm, you should have X11 forwarding already enabled. So let's log out and log back in. So here's my login from previous, and I'm going to just log in now with the -X, -Y flags and hit enter. Provide my passcode again. And so there I am, I'm logged in, and I'm going to hop to a dev node. Right. And I'm going to open any GUI program that I'd like. So here, automatically loaded for me is MATLAB, and let's open MATLAB. And there, the MATLAB program pops up. This is not MATLAB on my local computer. This is using MATLAB on HPCC. And if I want to quit this program, I can either quit here, and then I can Control-C and get my command prompt available here to me. So here I am, I'm logged into HPCC. I've just hopped to a development node, and you can see that my current location is still my home directory. I'm still in terms of my file system, I'm within my personal file system on home. If I want to go to my research file system to see the file systems that you have access to, you can just type groups, and here you can see the research file systems that I have access to. So let's go to common data. So I would cd mount research common data. And so now you can see here that I am in the common data research space, not my home directory. If I wanted to go back home, I just cd, and there I am, I'm back home. And if I want to go to Scratch, I can cd, and then I can use this variable $scratch for Scratch, and now you can see that I am in my Scratch space. And if I print my working directory, you can see that I'm in GS18 Scratch username. So that's how you navigate to different file systems and how you jump to a different node. If you want to open a GUI program in HPCC, once you've loaded the module, just provide the name of that program. So let's open gvim. Gvim is the GUI editor for Vim that's available automatically on HPCC. It's in your environment once you have logged in. And you see a window pops up, and I can begin editing. I on the keyboard allows you to enter edit mode. And I can say this is a test. And then if I'm done editing, let's save this guy. So here you can see that the default location of this file is in my current working directory, which is on GS18 Scratch. In the left-hand bar here, you can see a number of locations that I can choose to save this file. and I'm going to choose to save it in my home directory. So here I am. I'm just going to save it in the main home directory. I'm not going to go to a subfolder, and I'm going to call this file test_file. And here I can save this. Right, and then there's a little note at the bottom there telling me that this file has been written. And so if I don't have any other updates here, I can just close this file. So file, close. All right, and that file has been closed. So here I'm going to close the program gvim, and I'm back in my terminal, and you can see that currently I'm in my Scratch directory. And so to go to the home file system where I have that file saved, I'll cd home. So I'm going to use the variable $home here, and this variable contains the path for your home directory. So my current working directory is my home directory, and you can see here in the prompt that I'm in my home directory. So let's take a look at my home directory. And here you can see that test file that I've just saved. This is how you'd go about using a GUI program on HPCC to save a plain text file on the file systems. Let's take a quick look at where I can view this file once I have placed it on the file system. Right now we're on the Dev Intel 18 node. If we were to hop to the gateway node, and we take a look at our home directory here, once again you can see the test file. If you hop over to the Dev AMD 20 node, and we take a look at our home directory here, you can once again see the test file in my home directory. You can use the regular Linux commands to move this file around. So let's say we want to move this file, test file, from my home directory to my Scratch directory. And I'm going to simply use the Scratch variable here. And so I'm expecting this file to be renamed with the same name, test_file. So let's hop over to the Scratch directory, and here we take a look, and you can see the test file is now in my Scratch directory. If I hop over to Dev Intel 18 and take a look at my Scratch directory once again, you can once again see this test file. If I exit the Dev Intel 18 dev node and I go to the gateway node, you'll notice that I automatically lose access to the Scratch file system. Even if I ls and provide the path for Scratch, I'm only able to view my home file system. The reason I'm not able to view my Scratch directory on the gateway node is because this node does not have access to the Scratch file system. And because test file is no longer on this system, I cannot see it here. If instead I log out and I log back in on the data gateway node, the rsync node, and I try to take a look at my Scratch directory here, so here I am, I'm on the rsync gateway node, and I take a look at my directory. ls once again just shows me my home directory, but if I provide the path to my Scratch directory, I am able to view test file once again. In summary, the main difference between your desktop or laptop and MSU's HPCC clusters is that there are a lot more computers or nodes on which you can run your computation, and each of these nodes has more cores than you'll find on a computer that's just off the shelf. While the speed of each of these cores is comparable with the processors on your home computer, the fact that each node in the cluster is networked to every other node via a high-speed network, you have many more processors available to you to distribute your work on. And this is what makes HPCC a really awesome tool in reducing the mean time to discovery. You also notice that you have access to super fast network file systems, such as your home and Scratch space. What you will also notice is that there are many users on the HPCC cluster compared with a single user perhaps in your home computer or just a handful of users. So if you want to use resources, compute resources, to say run a program, you cannot have those resources available to you on demand. You must first schedule them. And so typically your request is placed within a queue, and that request accrues priority based on a number of factors which we will discuss in subsequent videos. I hope this video gave you a good sense of the layout of MSU's HPCC and how you can gain access and begin working on the system, as well as which resources might be useful for your particular workflow. If you're part of the MSU community, feel free to reach out to us with questions at contact.icer.msu.edu. Thanks for watching.